Hello everyone. In this video, we're going to talk about association between two quantitative variables. So in the last video, we focused on association between two categorical variables, or what you can do in describing two categorical variables together. So how does it change when we turn from categorical to quantitative? Just like in the one variable case, it turns out that we can do a lot more with quantitative data than we can with categorical data. So basically what we could do last time was we could make a contingency table and we could make percents. Okay? And something that I didn't really touch on in the video and that you may read about, but we just won't focus so much in this class, is that we can make statements about association or non-association between categorical variables. We just aren't focusing on it now. We will actually, I misspoke there, we will focus on it later in the course, okay, in just a little one lesson about it, okay? But right now we're going to skip over it and talk about association between quantitative variables. So when we have two quantitative variables together, how we plot them is with what's called a scatter plot. Okay? And a scatter plot is a bunch of points, and each one of those points is an XY pair. So you've probably had some exposure or some familiarity with scatter plots. Okay, so this here is a scatter plot of engine displacement on the X. So it would be my explanatory variable, and then highway MPG on the y-axis, it would be my response variable. Okay. So what else can we do? We can plot it, and then we can sort of describe it. So how are we going to describe this relationship? Well, one is a basic association. Okay. And so another way I'm going to talk about this is the direction of the relationship. Okay, so I'll call it the association here. This is maybe somewhat misleading. Association can be a very large and encompassing term. Here I mean it very literally in the direction of how the plot goes. Okay, and that's all I mean. So here, positive association means when values of the explanatory variable increase, the response variable increases as well. Okay, and then a negative association means that when values of the response decrease as the values of the explanatory variable increase. Okay, so that may be a little confusing. It'll be much easier with plots. So here are the plots. On the left plot, you'll see engine displacement versus highway, that first graph, and you see a negative association. As the values of X increase, the values of Y decrease. So we have engine displacement and highway. And so if you think about the data for a second, as your engine gets larger, okay, or the displacement of the engine gets larger, which generally means the engine will be larger, the car is going to get bigger, and so the MPG is going to go down. So that's a negative association. Okay, you can think of a negative association, an example that a lot of people like to use in stats courses is the number of classes you skipped is negatively associated with your grade. Okay, as the number of classes goes up, your grade generally goes down. All right, so that's a negative association. On the right side, I have a different data set that we've seen a bunch. It's the diamonds data set, and I'm plotting caret versus price. Okay, so the number of carats versus is my explanatory variable, and the price is my response variable. And so you would think, as we all know, the bigger the caret, the more the price. And so that's what you generally see in this plot, is that as caret goes up, price goes up as well. All right, so that's the direction of association. So I'll often talk about direction of association. That's what I mean in direction. We can also talk about how strong or weak the association is. So, for instance, if I have a scatter plot like this, okay, and you look at this closely, this is just a random scatter plot that I've made. X and Y have no real meaning here. And so you want to look and first maybe describe the direction, okay? And that sort of gives you the strength as well. As X increases, does it look like that? Does it look like Y is increasing, Y is decreasing, or Y is doing nothing at all? And so if you think about that for a little bit, you probably notice that it doesn't look like Y is doing anything as X increases. There's values that are high, values that are low. It looks like X has no effect on the values of Y. Okay, and so maybe it would be easier if there were units associated. If you thought about caret on the X and then price on the Y, this would be saying that caret has no value or doesn't matter about the price at all. Okay, so that's what this graph would indicate. Of course, we know that's not real because we saw that last plot, which is from real data. Anyway, this value, or this plot, okay, indicates no association. It doesn't matter what X is. It has no effect on Y. Okay, so that's no association. I have a second plot here. Look at it. See if you can describe the direction. Hopefully you see that it's positive. Okay, as X increases, it looks like Y is generally increasing. But there's a lot of variability in the points. Okay, so I have some very low values for low values of Y, for low values of X, but I also have some pretty high values of Y for low values of X. Okay, so you can see that there's a picture of some association there. Okay, it's as X is increasing, generally it looks like Y is increasing, but it's not the clearest picture. That is weak or moderate association. So this would be probably in the middle. Okay, I wouldn't say it's really weak, but I wouldn't say it's really strong as well. And then, of course, there's a third example here. Okay, and if you look at this, it looks like as X increases, Y increases, and it's a really clear picture about what's happening. There's not a lot of variability in the points. Okay, so it almost looks like it's a line. Okay, so there's some variability, but not a lot. That is a strong association. Okay, so we have three examples: no association, weak / moderate, and then strong. So hopefully that gives you a picture about the strength of association. The less variability there are in the points, the more closely they are together, the stronger the association. Okay? All right. When it looks like the variables have a linear relationship, we can actually do something more than just look at the direction and the strength. Okay, so before, for the direction and the strength, our scatter plot didn't have to look linear. Okay, and so what do I mean by that? Let me go back here. So I have these three plots. all three of these, maybe not the first one, the no association, we can't really tell what the heck's going on in that plot, okay? But in the second and the third plot, it looks like as x increases, y increases in a linear manner. And what I mean by that is if we put a line, or what we're going to call fitting a line, if we fit a line to that data, it would look like I'm doing the right thing by fitting a straight line to that data. So if anyone is following the coronavirus, any sort of coronavirus data, at the beginning of this epidemic, people used the word a lot, exponential growth. Okay, exponential growth. And so sometime in your mathematical career, you've probably seen exponential growth. Okay, and that means as x increases, y increases, but not in the same way along x. So if you look at the strong association plot here, it looks like y is going up about the same amount for every increase in x I have. Okay, that is linear. But if the points really shot up as x increased, then that's probably not so linear. Without drawing, I can't really give you a straight picture, but if you look up exponential growth, or you look up how this COVID-19 data shows that it's spreading early on, what happened in early March, late March, early April, you'll see an exponential growth pattern. And so it would that would not be linear. All right, so again, sorry for the side note, happens all the time. When two quantitative variables have a linear relationship, we can summarize that. We can summarize the strength of the association with a single number, okay? Not just saying it's strong or weak. We can actually give a number that describes how strong it is, all right? And so before I keep going, I bolded here linear relationship. And I did that for a specific reason. We can only use this number, which we're going to find, which is called the correlation coefficient, if the data have a linear relationship. If there's not a linear relationship, then we cannot use what I'm going to talk about. And so if there's anything you take from this slide, you write that down. We cannot use this number if the data does not look linear. Okay, so now that that's out of the way, what is the correlation coefficient? First, what do we denote it as? So we have a lot of symbols in this class, and that's going to continue on. We denote the correlation coefficient with the lowercase letter r, okay? And the possible values that the correlation coefficient can take on is any number between -1 and 1. And it can be -1, it can be 1 as well. Okay? And so the extremes represent something special. So -1 represents a perfectly negative linear relationship between x and y. 0 denotes no relationship between x and y, so it would have been that no association picture that we saw before. And 1 denotes a perfectly positive relationship. And so I've put here the formula for making the correlation coefficient. You don't need to worry about this. I'm not going to ask you about it. It's just there for completeness. Okay, so here's a picture that gives you 6 different plots and then tells you what the correlation coefficient is for each of them. So it'll give you a graphic picture of what the correlation coefficient means. And so you'll see in the top 3 pictures, you'll see the extremes. So if the correlation coefficient is 1, the data, the points, fall on an actual line. Okay, so if I put a line through 2 of those data points, it would go through all of the data points. The same way with the other one, only now as x increases, y decreases. Okay, so that's r equals -1. And then, of course, r equals 0, there's no pattern whatsoever. All right? And then in the bottom 3 pictures, we see the sort of in the middle, which can be quite subtle. Okay? So you'll see an r equals of 0.8 is actually a pretty strong association. Okay? R equals 0.8 is a pretty strong association. You'll see it's an upward association. Okay, it's positive. R is positive, so it goes upward. Okay, and it's fairly, and the points are clustered, quote unquote, fairly closely to a line if I drew a line through. Second picture, it definitely looks like there is a positive relationship, but it's more muddled. It's not as clear. And then r of -0.7, it's a fairly strong relationship, but it's going downward. So it's negative and then 0.7. Okay, so again, here's the reading assignment for the set of topics that I talked about. Okay, and the your turn at the end of this is a website. Okay, so there's or not a website, but there's a web-based game that will give you random scatter plot pictures, and then it'll ask you to guess the correlation for those. And so usually I show this in class, and I show how big of a nerd that I am, because I usually can guess these fairly accurately. Okay, but I won't do that here and embarrass myself on the video. So here's where I'll stop. I'll see you next time.